This is the diagram of a triangle, and I have written the cosine rules for the triangle. So ABC, capital ABC, they are the angles, and arm lowercase a, b, c, these are the arms, uh, three arms of the triangle. So this is the cosine rule, and I will try to prove them. So in order to do that, first what I will do, I will just do one for one, and then we can deduce the rest. The proof of the rest will be similar. So this is the first one. So I am drawing a perpendicular from vertex A to opposite arm. This is small a, lowercase a. So this point is, let's say, D. So we can say A is BD plus CD. So BD plus CD. Let's leave it there. Now, when we look at the right triangle, let's say ABD, that means this one here. So if we look at that triangle and the angle here is B, so we can write cosine B, cos B, from the basic definition of cosine is BD over C, because it's adjacent arm and this is the hypotenuse. Adjacent over hypotenuse is cosine. So BD can be written as C lowercase c cos B, that is BD. Similarly, we can, for CD, we can write, if we take angle cosine of angle C, from the basic definition it will be, the definition of cosine will be CD, which is the adjacent arm, and the divided by the hypotenuse, which is B. So CD can be written as B cosine of C. So BD is C cosine of B, C cosine of B, plus CD is B cosine of C, arm B cosine of C. So this is A. And in similar manner we can show. So what we can do, we can take this arm, this angle, and draw a perpendicular up to there, up to the point in SC1 point, and we can find the angle for let's say for C, and for A we can represent the arm B in terms of those two other two arms and the angles. So that will be, if we look at this one, that we can see a symmetry, and I will just write from that. So B will be A cosine of C plus C cosine of A. Similarly, for C will be B cosine of A plus A cosine of B. Now we need to prove, let's say we want to prove this one. So we want A square. So let's take this equation, the first one, and multiply both sides by A. So we get A square here, and this is becoming AC cos B plus AB cos C. Then we take the second one, which is this one, and multiply this both sides by B. So it becomes B square, and this is AB cos C plus BC cos A. So this is the second one, and the third one, if I go to the next page, taking this equation and multiplying both sides by C, it will be C square is equal to BC cos A plus AC cos B. So let's call this equation 3, this one 2, and this one 1. Now we need to we want to prove the first one here, the first form of cosine rule. And if we want to do that, what I will do, I will take 1 and subtract 2 and 3 from that. So what I have is on the left hand side a square minus b square minus c square, that I have on the left hand side. On the right hand side I have here ac cos b, and I will look if I have the same thing anywhere else, and I can see it is there. So since 1 to 1 3 will be subtracted from 1, these two will get cancelled, so I will just cross them out. This one and this one will be crossed out. Let's see this one, second one, AB cos C. I can see AB cos C here as well. So 2 will be subtracted from 1, so this will get cancelled as well. Now this one, since 1 minus 2, so this one will come as a negative, and this is the same thing which will come as a negative. So we will have BC cos A minus BC cos A. That is the only thing we have on the right hand side. So if I rewrite this one, take these two on the right hand side, b square plus c square, and this one becomes 2bc cos A. So this is my first cosine rule, which is this one. This is proved, and the remaining two can be proved in similar fashion, of course. So yeah.